Hey, so hi everyone. Today I will be presenting different word problems that involves linear expansion. So for the first one, we have here the Humber Bridge in England has the world's longest single span of 1,410 meters. Calculate the change in length of the steel deck of the span when the temperature increases from negative 5.0 degrees Celsius to 18.0 degrees Celsius. Now, the given coefficient of the thermal expansion for steel is alpha equal to 1.2 times 10 raised to negative 5 degrees Celsius raised to negative 1. So to solve for this problem, we will first try to read it. So the given here, we have your L naught for your initial length, which is your 1 for 1,410 meters. And then our initial temperature, that's negative 5.0 degrees Celsius. And then our final temperature, which is the 18.0 degrees Celsius. And then we also have here our thermal coefficient of thermal expansion for the steel, which is the 1.2 times 10 is to negative 5 degrees Celsius raised to negative. And then our formula to be used in this problem is our formula for the linear expansion, which is the delta L equal to alpha L naught delta T. And then we will first solve our delta T since we are already given with the alpha and then our initial length. Now we will solve for delta T, which is equal to our final temperature minus our initial temperature. That is 18.0 degrees Celsius minus negative 5.0 degrees Celsius. Now this will give us 23, okay, positive 23.0 degrees Celsius. Okay. Now we are ready to solve for our delta L. So let's plug in the values. Your alpha is 1.2 times 10 raised to negative 5. I'm sorry, that's the unit is degrees Celsius raised to negative 1 times our initial length, which is the 1,410 meters, times our delta T, which is 23.0 degrees. And solving this using your calculator, you will get positive 0.389. Now this is our delta or our change in length. When you see this delta, it indicates change. So delta T, that's change in temperature, and then delta L, that's change in length. So this is now our final answer. Now notice that with the positive sign, it indicates that our length increases as the temperature increases. So notice that our temperature increases or increased from negative 5 to positive 18. And so our length also increases at a rate of positive 0.389. Please note that this is also in connection with our discussion where I told you that an increase in temperature or the more hotter the environment is, the object expands. So in this case, our steel deck that is a part of the Humber Bridge expanded when the temperature increased. So this increase in temperature indicates that the hotness or the the hotness of the environment also increased or must immediately environment happened. So that is the reason why there is also an increase in the level. Okay, so for the next example, we have here a surveyor uses a steel measuring tape that is exactly 50 meters long at a temperature of 20 degrees Celsius. So the markings on the tape are calibrated for this temperature. What is the length of the tape when the temperature is 35 degrees Celsius? Now, the given coefficient of thermal expansion for the steel is equivalent to alpha equal to 1.2 times 10 raised to negative 5 degrees Celsius raised to negative 1. So the first step in solving this problem, again, we will write our given. Our L naught here is 50 meters or 50.000. And then our initial temperature, that is 20 degrees Celsius, and our final temperature is the 35 degrees Celsius. Now, what we are looking for in the problem is our final length, or our length at 35 degrees Celsius. Also, another given, we have here our alpha, that is 1.2 times 10 is negative 5 degrees Celsius is to negative 1. And then the formula that we are going to use is our formula for linear expansion. That's delta L alpha L naught times delta T. Now let's solve first for our delta T. That's T minus T naught, or 35 degrees Celsius minus 20 degrees Celsius. Now this will give us 15 degrees Celsius. Now plugging in the given values in our formula, this one, so it will give us delta L is equal to 1.2 times 10 is to negative 5 degrees Celsius is to negative 1 times our delta L, that's 50 meters, times our L naught, that is 50 meters, and our delta T, that is 15 degrees. Now solving this using your calculator, you will get 9.0 times 10 raised to negative 3 meters. And this is also 0.009. So this is now our delta L. Now what we are looking for in the problem is our final L, okay, this one. So your formula for delta L is actually your final length minus your initial length. Now, transposing to the other side, our L naught, so I will transfer this one, or I will transpose this to the left-hand side. We will have delta L plus L naught is equal to L. Now this is now our equation for solving L, or you can reverse it or write it in reverse. That's L equal to delta L plus L naught. So our delta L now, that's 0.009 meters plus our L naught, which is 50 meters. Now adding the two, you will get 50.009. Now this is now our final length, or also our final answer. It means that this is the length of the steel measuring tape at the temperature 35 degrees Celsius. Okay, now for our last example, we have here the outer diameter of a glass jar and the inner diameter of its iron lid are both 725 millimeters at room temperature, that is 20 degrees Celsius, What will be the size of the difference in these diameters if the lid is briefly held under hot water until its temperature rises to 50 degrees Celsius without changing the temperature of the glass? Now, what is asked in this question is the size of the difference in these diameters. Now, what we are going to solve is the diameter for the iron lid. Now, since an iron is made up of steel, so we will consider the thermal coefficient for the steel, or the coefficient of the thermal expansion for the steel, that is equivalent to 1.2 times 10 raised to negative 5 degrees Celsius raised to negative 1. Now, first, we will write the given. Our given in the problem, we have here our initial length, or the diameter of the iron lid, is 725 millimeters. The initial temperature, or at room temperature, that is 20.0 degrees Celsius, and our final temperature, that is 50.0 degrees Celsius. We also have the coefficient of thermal expansion for the steel, 1.2 times 10 is negative 5 degrees Celsius raised to negative 1. Now, what we are looking for in the problem is the word difference in the diameter. Now, we will use, or we will look for the delta L. Okay, since delta L also presents or also gives the difference in these diameters, or the difference in the length of this diameter. So the formula for this problem have here formula that is delta L equal to alpha L naught delta T. Now we will solve for delta T. That's T minus T naught, where that's 50 degrees Celsius minus 20 degrees Celsius gives us 30 degrees Celsius. Now this is now our delta T. We will substitute these variables to the formula, or these values to the formula. We now have 1.2 times 10 raised to negative 5 degrees Celsius negative 1 times our initial length times our delta T. So always take note of the units. Your units has to have, your units must be consistent. If you are using degrees Celsius, dapat degrees Celsius lahat. If you're going to use millimeter, dapat millimeter lahat. So calculating this, it will give us 0.26. Now, the unit here is millimeter. Since we use millimeter in calculating delta L. So this is now our final answer. So it means that the size of the difference in this diameters when the glass jar is held under hot water is 0.26 millimeters. So that's the difference. Okay, so thank you everyone for listening. Thank you for watching this video. If you have questions, clarifications, and other suggestions, you can send me a message through my Facebook Messenger. That's all for today. Thank you and God bless.